walk you through this, then we'll do a couple together. I'll flip over and try to use my iPad, so you get to watch me flip in and out of different modalities here this morning. So the range game works like this. So in general, you provide a number that when combined through addition, subtraction, multiplication, or division, with the number list creates a result that falls within the range listed on the number line. So I'm going to ask some of you to unmute and kind of share here. So basically the question is, what added to 2/3 equals something that falls between 0 and 1? Okay, so pretty open-ended. Does someone want to offer up an option? We won't write it down here until I switch to my iPad in a few minutes, but what added to 2/3 equals an answer that will fall between 0 and 1? Someone give me an answer.
1/8.
1/8. All right. So Anna, I believe, is who spoke up. I can't see everybody at once, but I think that was Anna. Thank you, Anna. Said 1/8. So I'm going to ask others to talk through how Anna knows that 1/8 will result in an answer that lies between 0 and 1. Someone defend Anna's answer.
Well,
I'll go ahead.
okay. So,
Yeah, Noah.
so 1/3 added to 2/3 is equal to 1. And since 1/8 is less than 1/3, 2/3 plus 1/8 is less than 1.
Okay, great. Well, you're unmuted. No, I'm going to keep you going because that was a good response. So if you're working with students and they're not so sure about that, how might you invite them to use some of the materials they have to provide answers here? Because we know we have some hands-on materials they're using. So what might you do if they're just like, I don't know where to get started?
Well, we don't have fraction tiles anymore. If we did, I would definitely have them do something like that and try to get them to see visually what they could do that creates, what fraction they could add to 2/3 that creates something that's less than 1. You could also do that with some other materials. You could use, I like using just like having them draw things out on a number line, or you could have them fill in like some squares or like that.
Perfect. And I think one of the things that's nice about the fraction tiles, while you may not have those physically now, hopefully students have a pretty good mental representation of those. So you could ask them to sketch those, or let's think about our fraction tiles. And I believe you all use the rectangular fraction tiles. And it's really nice because on lined paper, students can just, make a really quick rectangle on lined paper. That's their one, and then just sketch those out a little bit. Okay, so thank you, Noah, and thank you, Anna. We have a great answer of 1/8. And I think we probably all agree that because 1/3 would anchor, the 2/3 plus 1/3 would get us to 1, that we need some fractional amount below 1/8. Someone give me another one. What's one more fraction that would fit in here to work to land with an answer between 0 and 1?
1/100th.
1/100th. Okay, nice. So just giving us a smidge more. Thank you, Brandon. Great. All right. So one of the things we always want to do with this, you're going to be working with hopefully 2 students, if they're both there that day, is that you would expect to get 3 or 4 answers from them. So keep pushing them. Don't keep them at 1, because the idea is to continue to generate, to deepen their understanding, and begin that, it's called the range game, that a range of answers would help this fall within a range. And so because we can use addition, subtraction, multiplication, and division, really, again, like many of the other warm-ups we use this year, the world is your oyster. You can create these in every which way to fit the mathematics that they're working on, or to keep engaging them in mathematics that you've worked on this fall. I think you probably already have a sense that there's probably not enough that we can do. We can continue every week to do work with integers and with fractions, and with a lot of our students, even just with whole numbers. They need review, they need revision, review, and then a continual going back to these concepts in different ways to just keep refreshing it. Okay, so let me ask this question. If someone said 1/3, which is often what happens with this particular question, what is some discussion that we could have here? And again, this falls probably a little bit more into my classroom teacher hat, where I would have 30 students in a room talking about this. But oftentimes the first answer out the bat is 1/3. And so what might you think we could talk about there, thinking about this notion of falling within the range listed on the number line? Are we okay with an answer of 1/3? I guess is what I'm asking.
Was it allowed to equal 1?
Yeah, great, Kate, thanks. Yes, I think the question is, can it equal 1? So again, in a classroom setting, which you're just working with a couple of students, I think you want to establish that. Like, what do we mean by falling within the range? So I think just engaging them in this discussion, if it comes up, and again, we want to ask for multiple answers from the students, because right away, if I'm 2 savvy high school students, I'm going to be 0. So, you know, if I add nothing to this, it's going to fall between 0 and 1. And then if I'm the next savvy high school student with my buddy that's being tutored, I'm going to say 1/3. We don't want the problem to be done at that point. We want to do a little bit more work with them. Okay, I'm going to shift. So the way this is going to go, we're going to do a couple more together. So you kind of get the drift of this and see some different options. And then I'm going to actually have you all make some and then be willing to share. Obviously, you won't be able to maybe share screen, but you can share what your range games are, because the idea is we'll give you a few and then you can generate a host more. So I am going to switch what I'm sharing from real quickly and get to my iPad. Sorry. Something terrible just happened. I deleted a bunch of things. Okay, there we go. Let me go back to sharing. Take me just a moment here to mirror. Okay. So hopefully you all can see my iPad here. I'm going to recreate this one. Okay, so we're asking the question, 1/2 times what equals an answer that will lie between 4 and 10. So I'll start taking some answers. So what do I need to multiply by 1/2 to get an answer that lies between 4 and 10?
16.
16. Okay, we have an answer of 16. So 16 times 1/2, or 1/2 of 16, gives us 8. Okay, great. Someone else.
12.
12. Okay, same thing. 1/2 of 12 gives us 6. Good. One more.
10.
10. Okay, I heard it from a few people. 10. All right. So you can see that one. Obviously, that one's designed a great quick warm up to remind students to think about 1/2. I could see a nice series to help students work with kind of the benchmark fractions and the more common fractions, to do a 1/2 and then maybe a problem with a 1/4, a 1/8, and kind of continue that way. So various ways you can do that. Let me do one more here with you. I think the next one I had was 9 divided by what equals, and then 20 to 50. So 9 divided by what is going to land me between 20 and 50?
1/3.
Okay, so we have a 1/3 on the board. Everybody agree that 9 divided by 1/3. So if I take 9 and divide it into thirds, how many pieces am I going to have, or how many holes, I guess, will I have at this point? Everybody agree with that one? It's going to get us 27. Okay, what's another one?
1/4.
A 1/4. Okay, everybody okay with that? Someone give me something that's going to get us closer to 50.
1/5.
1/5. Okay, great. All right, so you can see how the range game works. Let me do, I have one more that I didn't have up here. I'm going to throw in something with some integers, so you can see those. Okay, so 10 plus what will fall within the range between -3 and 1. So I straddled 0 here.
-11.
Okay, -11. All right, so -11 is going to land us directly on the 1. So that's great. That raises that issue of, do we want to include 1 or do we not? Or do we need to just be rubbing up against it or not? I think either way is fine. Just make sure to have that conversation when it comes up, because it's kind of about vocabulary and establishing, in the community, what do we mean by falling within a range? Okay, another answer? Can someone give
-10.
-10? -10 or just 10? Sorry. -10, I think is what I heard. Okay, great. So it gets a 0. Or sorry, a moment ago when I was talking about -11, that would have landed us at -1. My apologies. Okay, so you see how this works. So what I want us to do now, first of all, let me just ask some questions. Let me get out of the stop sharing here for just a moment, so I can see everybody. So how do you think the range game will go? Just responses for how you've been tutoring for a while, your students pretty well, except for a couple of new people that are joining us. Do you think this is something you can use with your students?
I've actually done this before with my students and they've really
Okay.
liked it. A lot of
Good.
times, like if we clean up and we ended up being done a little bit early and we had a few minutes, I would just kind of sit there and do things like this where they actually had to think about it and couldn't write things down to see if they could kind of visualize it. And
Sure.
they seem to like it.
Great, good, good, good. Other comments or thoughts? It feels a little bit like the math dice game, that we taught you, where you're having 3 numbers and so on, but it just changes it up a bit. Okay, so let me go back here. I'm going to share again. And then kind of go over, the highlights of this particular warm up. And then I'm going to ask you all to make a couple. So obviously, warm ups are great when they have multiple solution possibilities in a single problem. Make sure you ask students to generate 3. And if they have solutions that are resulting, just make sure that they're generating their own. And then with the right kinds of questions, even though we're not going to get into this, so you can tell I'm using a slide here I use with teachers, you can begin to kind of develop this idea of limits. So again, if you don't include the bounds, the 2 ends, you're thinking about how close can I get it to that? So that's another way you can engage it. What can we keep doing? What could we keep, especially with addition ones with this age students, so they can keep adding something with more decimal places to get closer and closer and closer to that endpoint, but not actually hit it. And then again, this can be used with all kinds of things. For us, I think we'd be using whole numbers, fractions, decimals, percents, integers, square roots, just whatever mathematics you get into this year. And then let's create some of these together. So obviously you're working with high school students, but I know we're working across a range of mathematics with the students. So create one using fractions. And I say appropriate for 5th grade students here. And then use one with integers that are appropriate for 7th grade students. Obviously, we could make the numbers that we're including in these extremely difficult, but we want these to be inviting for students to be able to do mental math for the most part. Not that they can't write things down, or not that they can't pull out their fraction tiles or fraction bars and use them, but we don't want to include things like, 37/40 seconds plus something, let's keep things friendly so we can invite students to work on them. So each of you create 2 different ones, one with fractions, one with integers, and then be willing to share out in just a few moments. Give us one more minute here and then I'll ask some people to share. Okay, I'm just gonna call on people. Hopefully you're okay with that. Shwanda, I see you down here in the corner of my screen. Can I ask you to share one you came up with?
Yes, so my one for the integer is 30 divided by a number equals to a number that falls between the range of 2 and 16.
Okay, great. So 30 divided by a number lies between the range of 2 and 16.
Yes.
Okay, great. So I immediately think of 2 as a possible answer. I'm sure others are thinking of things. Okay, great. Good, good, good. Let me see who else here. Avery Madden, can I have you share one?
Yeah, so it's kind of hard to see here, but for the fraction one, I did 1/2 plus blank goes from 0 to 10.
Okay. So an addition with fractions, all right, great. So 1/2 plus what equals 10, and lots of possibilities for that with some whole numbers, but also a lot of fractions. And again, I think you can push people to say, I want your answers to all be fractions if you wanted to with that kind of problem. Okay, let me ask someone, Daniela, can I call on you to give us one with integers?
Yeah, no problem. So I did from -5 to 5.
Okay.
7 plus what?
7 plus what equals, okay, nice, good, good, good. All right, so you can see there are just a host of these. I suspect we have maybe a couple alike across this large group, but I suspect if all of you created 2, we have 48 times 2, maybe minus a couple different options. So you can really use these in a variety of ways. Again, I think what's great about these kinds of warm-ups is they're so flexible. We talked about this at the beginning of the year, but we were all new to this project, so I'll remind you again, is that by using the same structure multiple times again and again with all kinds of possibilities, you remove the cognitive load from the students for learning the structure. So they just know what to do after you teach them how to do this, and then you pull it up and you get right into the mathematics, not having to explain how to do the warm-up. So go back to, your math squares, recycle those, your 2 ways. Now you have range game, I notice, I wonder. And then we're going to do one other a little bit later today. So we'll just kind of hop in and out of mathematics as we go. All right, back to you, Christina, I think.
Okay, I'm going to first stop the recording so that we have